Good morning, everybody. Today I'm going to talk about the chapter 3 and 4 from the OpenStack book. And this book, as I mentioned, is free to download. So please follow the book. And if you have any question understanding the material, do not hesitate to contact me. And this is such an exciting topic you'll learn. In this topic, you learn about the motion, energy, gravity. We'll also talk about the tides, the Kepler's laws. So, what is the motion? We'll start with what is the motion. Let's start with the motion. So, the motion, what is the motion? Simply to describe the motion is the position changes with the time. For example, you are in the room and I'm in my office. And if let's say I started at 5 o'clock, and even at 6 o'clock, if I'm sitting there, then basically I do not have any motion. If I'm sitting there, that means my position is not changing with the time. But if I'm moving around, my position, my coordinate, my location is changing with respect to the time, then that means I do have the motion. In order to describe the motion, we have two fundamental quantities, the speed and the velocity. Both describes the motion. The speed is simply a scalar quantity. It doesn't have any direction. If I'm saying I am moving with the 5 meters per second, it could be in any direction. It could be east, it could be west, it could be south, it could be north, or any possible direction. That means a speed is simply a scalar quantity. It doesn't have any direction. But now, if I say I am moving with 5 meters per second towards east direction, that means I am giving well-defined the direction. That is the velocity. That's the only difference. The speed here, you see the speed here is a scalar quantity. This is a scalar quantity. Scalar. While the velocity is a vector quantity. Oh, sorry. This quantity is a vector quantity. Vector quantity. When I say vector, again, this means it does have the direction. Now let's talk about let me give you one more example. Let's say from Odessa to Dallas. I need to go to the Dallas from Odessa. If I need to go to Dallas, I have to move in one particular direction, which is towards east direction. If I move towards any other direction, I may never reach to the Dallas. That means although I am moving, and if I'm moving in a well-defined direction, then that is the velocity. The speed could be in any direction. Okay, and the unit of the velocity and the speed is the same as meter per second. Now let's talk about the acceleration. What is acceleration? The term acceleration means the change in the velocity. If something is changing or if the velocity is changing with respect to the time, that means it does have the acceleration. Here, for example, the car here. This car started from 30 km per hour and now it is moving with 60 km per hour. That means the velocity is not the same. When the velocity is not the same and it changes with the time, that means there must be some acceleration. In this case, the acceleration is positive. It is increasing with the time. In this case, in the second case, you started with 60 kilometer per hour and you have a stop sign there. What do? You press the brake, then you come to a stop here. Again, as you're seeing, the velocity is changing with respect to the time. If the velocity is changing with respect to the time, then that means there must be some acceleration. Whenever there is an acceleration, there is a force acting on it. Without the force, you would never be able to stop an object. If it is moving, you have to apply the force. The third example is a very interesting example. And the reason is, you see, in this case, the car is moving with a uniform speed, 60 kilometer per hour, but it is moving in a curved path. If it is moving in a curved path, even with the same speed, that means the velocity is not the same. The velocity at each location is different. Although the magnitude is the same, the velocity is different. Why is that? At this point, the velocity has this direction and this direction. And if I look at this point, the velocity is along this direction. At this point, the velocity is along this direction. If I draw a tangent, this direction. So the velocity has a different direction at the different time, although the magnitude is the same, which is 60 km per hour. In other words, we say the car is moving with the 60 km per hour speed, but its velocity is different just because the direction is changing. As the direction changing, so is the velocity. Or we say that it does have some force acting on it. Without the force, you will never be turn an object. When you're driving a car and if you're moving on a curved road, you must have to apply the force. There is force, or there is an acceleration, and you observe like when you're going around a path, your body tends to fall towards the opposite direction. That means there is a force acting on it. I hope you got this concept. In order to make it simple, whenever the velocity is changing, there must be some acceleration, or there must be some force acting on it. Or whenever you're moving in a curved path, even with the same speed, there must be some force acting on it. Without the force, you would never be able to turn a car into a curved path. All right, and the unit of the acceleration is meter per second square. You see this unit here, the meter per second square. Now let's talk about the acceleration due to the gravity, and this is denoted by the small g here.